हेलो ऑल। आज का प्रॉब्लम है एक सिंपल ज्योमेट्री का प्रॉब्लम है। आई थिंक ये प्रॉब्लम रीजनल मैथ्स ओलंपियाड या फिर प्री आरओ में किसी में आया था। एंड यही कॉन्सेप्ट यही दिस कॉन्सेप्ट पे एक आईआईटी जेईई एडवांस टू 2021 में भी प्रॉब्लम था। प्रॉब्लम गोज लाइक दिस: you have to prove that mirror image of ortho center over the side of triangle lies on the circumcircle of triangle. So what does it says that you all know what is ortho center. If not, I will explain it. So ortho center of a triangle, if the mirror image of that on the side of the triangle, then that point which is the mirror image that lies on the circumcircle of the triangle. And what is circumcircle? Circumcircle is the circle that passes through all the three vertices of the triangle. So let me explain this in a diagram and you will get it. So this is your triangle ABC. So what is the orthocenter? Orthocenter is the point at which these altitudes from the vertices to the other side intersect. For example, when you draw a line which is perpendicular, for example, you draw a line which is perpendicular to BC from A and a line which is perpendicular to AC from point B, then let me say this is X, this is Y. So this point is orthocenter. Okay, and what you will find that, like, when you, this will be also 90 degree. So when you draw a line which is perpendicular to the other side AB from the vertex C, then that will also pass through O, right? So that's the orthocenter. Now you now understand what is orthocenter, right? Now the problem, what is problem was saying? Problem was saying that you have to prove that the mirror image of orthocenter, okay, over the any of these two lines, right? It could be on this line mirror image, on this line mirror image, or this line, right? It passes the point which is the mirror image is passing through the circumcircle. And what is circumcircle? Circumcircle will be one circle that passes through all these points, right? Now this is your circumcircle. So what does it says that mirror image? So what would be the mirror image of O on the line AC, right? So it will be something like, let's say, so XY, this let's be P, right? So this point P, you have to prove that it passes through the circle which passes through all the vertex of triangle. Okay, so let me first erase this circle so that you don't get confused. Okay. Now basically, this is the orthocenter. This is the point P. This point P is actually the mirror image, right? Point P is, let me make it Y, and this is the point P which is the mirror image, right? And right. So when you say mirror image, what do you mean, right? Means if this is this is 90 degree and the length this will be equal to length this, right? So the point you get is the mirror image. For example, what you do, you find a point P which is mirror image O over the line AC. You draw a perpendicular which is already drawn, which is like, and then you measure this size OY, and then you kind of find a point P which is at equidistant from Y to this side, right? So this is the point P at which is the mirror image. So now this, which means this this means that your OYC, angle OYC is 90 degree. That is the first thing, right? And the second thing is your OY is equal to PY, right? So this OY will be equal to PY. Now this is clear. Okay. Now if we have to prove that P lies on a circle that passes through all ABC, what are the various ways? Remember the properties of circle, right? So let's say when you have a circle, remember that if you draw a triangle on the circle, so over this chord, if there is a triangle, and let's say this is angle X, you draw another triangle, this is also X, this angle will be also X, right? So let's say this was a point A, this was a point B, right? So in short, if you can say that hey, you had a triangle ABC, this was angle X, correct? Draw another triangle which is also X, and the value, let's say, was P, right? Point P. Then you can prove that this A and P, right, will be on a circle, right? Because this is the property in triangle, right? In circle, that a triangle inscribed within a circle, if the angle is X, another point which forms the circle with the same chord, the angle will be also X, right? Correct? So let's say if you have to find that hey, P lies on a circle which passes through A, B, C, right? What can you do to show that P is on that circle passing through A, B, C? Right? You see that this is a chord, right? This is a line which kinds of connect 2 points on the circle, which is A and C, right? And this is one angle, right? And what is this angle? This angle, let's call it theta, or we can call it C as well, but let's call it theta, right? And in your other angle, right, so this the point, the line is this, right, and this is theta, right? So for AB, this is the chord, AB is the chord, right, and this angle is theta, right? Now you join A and P. If you are able to prove that this angle is also theta, right, because now this is also a chord AB, common chord, and this is also theta, then you know that this angle and this angle are same. And when these two angles are same on the same chord, you know this is a property on the circle, on the triangles inscribed in a circle. So you know intuitively that point P and point C will be on a circle, on the same circle. And you know the circle that passes through point C, point B, point A is circumcircle. So it means the line P will also be it will be that which will be on the circumcircle. And what is point P? The point P is the mirror image of Ortho Center over the line AC. Okay. So what you need to prove now? If you can prove this angle APB is equal to angle ACB, then this will imply that point P and point C are on a circle, right? Which means that point A, P, B, C are on same circle, right? Therefore, and what is the circle that passes through point A, B, C? That is circumcircle. And hence you will be able to prove that point P also lies on circumcircle, right? So now you have to just focus on proving this is theta, this is theta. Okay? So how do you get that? Okay, let me erase all of this. So one way is, let's assume this is angle theta, and you try to find this angle in terms of theta, right? And if you are able to find this in the terms of theta, then you will be able to get the value. Okay, so now let's do this. If this is theta, okay, right, and this is 90 degree, what is this angle, right? This angle will be 90 degree minus theta. It's self-explanatory. This is 90, this is theta, this is 90 minus theta, right? So second thing, right? Other thing which you will be able to see that this triangle AYO, right, and this triangle, right, AYP are concurrent triangles, right? Which means, and which is like they have a common side, they have two common sides, right? This. So if you can apply the concurrent triangle theorem on this, right? There are two sides, so triangle AOY and triangle AYP are congruent, sorry. It's called congruent triangles. Okay, so congruent triangles. And why? Because this is a common side. This length is equal to this, and this side and these two sides are equal, right? So from what is this several ones, right? SAS theorem, right? Two sides are equal and including angle, right, of two triangles are equal, then they are congruent triangles, right? So now because these two are congruent triangles, right, what it does means the sides will be also equal, right, which means these three will be equal, these three will be equal, right, and also will mean this angle will be also equal, right? So this will be also 90 minus theta. This is 90, this angle will equal to this angle, this will angle to this angle. So this is also 90 minus theta. Now look at this triangle AYP, right? So what did we say? We found out triangle AYO and triangle AYP are congruent. And since they are congruent, you can say that angle OAY is equal to angle YAP, correct? And what was your angle YAP? Angle YAP is what you have to find. Angle OAY, it was 90 degree minus theta, 90 degree minus theta. So angle YAP is also 90 degree minus theta. So this angle is your 90 degree minus theta. So what is this angle? Easy, right? Sum of these three angles in a triangle is always 180 degree, right? So in triangle AYP, you can say that angle YAP plus angle AYP plus angle APY is equal to 180 degree, right? Three angles of a triangle is always 180 degree, and when you substitute the value, what was YAP? This is 90 degree minus theta, right? What is AYP? AYP is 90 degree, right? And this is angle APY equal to 180 degree, right? Now this is 90, 90 and 180. This will cancel out. So what will be remaining? Remaining will be angle APY is equal to theta. So you will find that this angle is also theta, right? And this is what we have to prove, that this angle is theta, this angle is same, and this angle and these angles are equal, which means that if you consider this as a chord of a circle, right, and this angle is equal and this angle is equal, right? So circle which passes through point ABC will also pass through point P, right? Because this is theta and this is also theta, right? So here is the proof, right, that the mirror image of orthocenter over a line on the triangle, right, lies on circumcircle, right? And you can do this over this line also, and you can do the same theorem, apply the same logic over, like, for O over the line BC and over the line AB, and you can similarly prove that every time you take the mirror image of O over a side of the triangle, the mirror image lies on the circumcircle. Okay, the next problem, in the next video I will explain how this concept was used in a problem in a coordinate geometry problem in JEE Advanced 2021, and that made it very simple problem. I will explain it in the next video. Thank you.